Video number 146 plus. 5 ideas. Hello! The outstanding physicist Fritz Zwicky witnessed the discovery of galaxies and the Hubble-Lemaître law. A good part of current cosmologists are only working on the original ideas that he introduced. The enigma of the missing mass, ghost light, the tired light hypothesis, neutron stars, and so on. According to his own account, Fritz Zwicky only had a good idea about every 2 years. During the past 5-year period, I have had 5 ideas, which very probably are not all so good, because it would be presumptuous for me to compare myself to such an inventive mind. These ideas have been exposed in various videos, and to allow interested people to find their way through the jumble of my videos on astrophysics, I will now recall them very quickly. 1. Atomic contraction. The idea is that electron orbitals undergo compression over a very long time. So, at a given energy level, electrons oscillated more slowly in the distant past. This can explain the redshift of distant galaxies without resorting to a dilation of space. This is therefore an alternative to the Big Bang model and tired light. This theory could also demystify the apparent gigantism of plants and arthropods in the Carboniferous. A more recent video introduces the modified equation, whose consequences are a little less absurd than for my initial model. 2. Free energy related to gravity. A very simple calculation allows us to evaluate the energy transported by gravitons within the framework of the push-gravity model introduced in the 17th century, repeatedly disproved and repeatedly reintroduced. What we can easily obtain, with very few assumptions, is a lower bound of the power crossing space of the order of a gigawatt per cubic decimeter. If we recover even a small fraction of this energy, we will never have an energy shortage again. 3. A link between orphan stars and ghost light. Stars not belonging to a galaxy are individually invisible through our best telescopes once their distance exceeds 1,000,000 light-years. But more and more are being discovered close to the Milky Way, only in pairs, and the conclusion would be that they are more numerous in intergalactic space than within galaxies. Their existence provides a possible explanation for the ghost light. 4. The stars, the spiral galaxies, fall toward the nucleus over a very long time. By what miracle do spiral galaxies have this shape? A spiral fall of stars toward the center could explain both central bulge and central black hole. Although I have not yet attempted to write down the corresponding dynamical equations, the model may be close to that invoked around 1750 by Leonard Euler for the long-term evolution of the solar system. 5. Antimatter never disappeared. For decades I believed the little phrase, "Where did the antimatter created with matter during the Big Bang go? Why is there only matter in our universe?" Since antiphotons are nothing else but photons, high-temperature antimatter emits electromagnetic waves that are strictly identical to those emitted by matter. It was recently confirmed that the emission spectrum of anti-hydrogen created in the laboratory is identical to that of hydrogen. If, for example, the Andromeda Nebula was made of antimatter, there would be no detectable difference with a galaxy made of matter. finally, nothing forbids us to imagine that half of our familiar universe is made of antimatter, contrary to what we have been told for decades. I don't know if I'll have enough time to produce other ideas of the same kind before my brain falls into the soft conformism that characterizes the modern world and increasingly rubs off on scientific research. Until then, stay tuned.